Good morning to all. I am Subarani, Associate Professor, Emmanuel Sir College of Pharmacy. Today's topic is PYRROLE. The content of this PPT is, first of all, introduction of PYRROLE, then physical properties of PYRROLE and chemical properties, and the synthesis of PYRROLE, some chemical reactions of PYRROLE, and medicinal uses of PYRROLE. Okay, first, physical properties of PYRROLE. It is a colorless volatile liquid. PYRROLE is a colorless volatile liquid. Its boiling point is 131 degrees Celsius and its melting point is 23 degrees Celsius. It turns brown in the air and gradually resinifies. So it is a colorless volatile liquids. Then its boiling point is 131 degrees Celsius and melting point of PYRROLE is 23 degrees Celsius. It turns brown in the air. In presence of air, PYRROLE turns brown in color and gradually resinifies. Only slightly soluble in water, but it is totally miscible with ether and ethanol. So, slightly soluble in water and totally fully soluble in ether and ethanol. PYRROLE is weakly basic in nature. PYRROLE has a relatively high boiling point as compared to furan and thiophene. Other heterocyclic compounds, furan and thiophene, only PYRROLE has been high melting point compared to furan and thiophene. The reason is, this is due to the presence of intermolecular hydrogen bonding in PYRROLE. Okay, so intermolecular hydrogen bonding present in PYRROLE. So PYRROLE have high boiling point compared to furan and thiophene. So these are the physical properties of furan. First, PYRROLE. First of all, it is a colorless volatile liquid. Then boiling point 131 degrees Celsius. Its melting point 23 degrees Celsius. It turns brown in the air. Slightly soluble in water, but it is totally miscible with ether and ethanol. PYRROLE is a weakly basic in nature. It's a high boiling point compared to furan and thiophene. So, it is due to the presence of intermolecular hydrogen bonding in PYRROLE. Okay, the next, chemical properties. PYRROLE is aromatic and more reactive than benzene. So, PYRROLE is aromatic in nature and more reactive than benzene. It gives electrophilic substitution reaction such as halogenation, nitration, sulfonation, etc. Then it also undergoes dissociation, diacetation and Riemann-Tiemann reaction, while benzene does not. So, PYRROLE undergoes diacetation and Riemann-Tiemann reaction, but benzene is not undergoes the diacetation and Riemann-Tiemann reaction. So, chemical properties, PYRROLE is in aromatic nature and it more reactive than benzene. It gives electrophilic substitution reactions such as halogenation, nitration, sulfonation, etc. It also undergoes diacetation and Riemann-Tiemann reaction, but benzene is not obtained in this diacetation and Riemann-Tiemann reaction. Okay. Then synthesis of PYRROLE. The preparation of PYRROLE. First method is from furan. Furan, by heating a mixture of furan, ammonia and steam over alumina catalyst. Furan is reacted with ammonia in the presence of alumina catalyst Al2O3 and this mixture is heated to form PYRROLE. Okay, PYRROLE and water molecule. The first preparation is from furan. By heating a mixture of furan with ammonia and steam over alumina catalyst. Furan is reacted with ammonia in the presence of Al2O3 alumina catalyst. It is heated, then the product of PYRROLE is obtained. Then second method is Polymer-pyrrole synthesis, Polymer method. It is a condensation reaction between 1,4-dicarbonyl compound with ammonia or a primary amine to form a substituted pyrrole is obtained. Pyrrole itself formed from succinaldehyde and ammonia. Okay, polymer synthesis, then it is a condensation reaction, 1,4-dicarbonyl compound. For example, acetyl acetone, 1,4-dicarbonyl compound with ammonia or a primary amine, NH3 for ammonia and primary amine, NH4 twice is 4. To form a 2 molecules of water is removed to form a substituted pyrrole is obtained. 2,3-dimethyl pyrrole is obtained. Another one method, pyrrole itself is formed from succinaldehyde and ammonia to form pyrrole. Okay, then this method is polymer pyrrole synthesis. It is a condensation reaction. 1,4-dicarbonyl compound acetyl acetone is reacted with ammonia in primary amine. It forms a substituted pyrrole. Okay. Then third method, Hanschig pyrrole synthesis. Hanschig pyrrole synthesis. The Hanschig pyrrole synthesis is the reaction of beta ketoester with ammonia. Beta ketoester with ammonia or primary amine and alpha haloketones to give substituted pyrrole is obtained. Hanschig pyrrole synthesis. This method is the reaction of beta ketoester with ammonia or primary amine, activated ketone with alpha haloketones. Alpha haloketone is reacted with activated ketone in the presence of ammonia to form a substituted pyrrole. Then from distillation of succinamide. Then fourth method is distillation of succinamide. Pyrrole is obtained by the distillation of succinamide with zinc dust. Succinamide is heated with zinc dust to form pyrrole and zinc oxide. So the fourth method is from distillation of succinamide. Pyrrole is obtained by the distillation of succinamide with zinc dust. Succinamide is heated with zinc dust to form pyrrole and zinc oxide. Then fifth method is from acetylene and ammonia. Pyrrole is obtained by passing acetylene and ammonia through a red hot tube. The formula of acetylene is CH triple bond CH plus ammonia NH3 to form pyrrole and hydrogen gas. So pyrrole is obtained by passing acetylene and ammonia through a red hot tube. Okay, then next, reactions of pyrrole. So 5 methods of preparation studied in the pyrrole. Then the reactions of pyrrole. First of all, acylation. Pyrrole is treated with acetic anhydride at 200 degrees Celsius gives 2-acetyl pyrrole, while N-acetyl pyrrole can be obtained by heating pyrrole with N-acetyl imidazole. So, first chemical reaction is pyrrole is treated with acetic anhydride CH3CO twice O. It is heated with 200 degrees Celsius. Pyrrole is heated with acetic anhydride at 200 degrees Celsius to form 2-acetyl pyrrole. The second position is obtained in acetyl group. So, 2-acetyl pyrrole is obtained. Then second chemical reaction is pyrrole is treated with N-acetyl imidazole. Pyrrole is heated with N-acetyl imidazole to form N-acetyl pyrrole is obtained. N-acetyl pyrrole is obtained. Okay. Acylation is completed. Then oxidation and reduction. Pyrrole is oxidized to maleimide and on reduction it gives pyrrolidine. First of all, pyrrole is oxidized chromium oxide CrO2 or acetic acid CH3COOH. Pyrrole is oxidized with chromic oxide or acetic acid to form a product maleimide. It is an imide of acetic acid. Imide of acetic acid is known as maleimide. Then pyrrole is reacted with zinc or acetic acid. Pyrrole is reacted with reduction with zinc or acetic acid to form 2,5-dihydropyrrole and hydrogen iodide or red phosphorus to form pyrrolidine. So, pyrrole is oxidized chromium dioxide and acetic acid to form maleimide, and pyrrole is reduction with zinc or acetic acid to form pyrrolidine. Okay. Then ring expansion. When potassium pyrrole is heated with chloroform and sodium ethoxide, the pyrrole expands to pyridine. 5-membered pyrrole expands to form a 6-membered ring that is known as pyridine. When potassium pyrrole is treated with or heated with chloroform and sodium ethoxide, potassium pyrrole, the H position is changed with the potassium ions K plus. Potassium pyrrole is treated with chloroform CHCl3 and sodium ethoxide C2H5ONa, sodium ethoxide, to form a 6-membered ring. Pyrrolidine is obtained. 3-chloropyridine or pyrrolidine is obtained. So this reaction is ring expansion. 5-membered ring is expands to form a 6-membered ring. Then Riemer-Tiemann reaction. In the presence of a strong base and a chloroform, pyrrole undergoes Riemer-Tiemann reaction to form pyrrole 2-aldehyde. Pyrrole is reacted with chloroform CHCl3 or KOH, potassium hydroxide, to form a pyrrole 2-aldehyde. The aldehyde group is obtained in second position. Okay, Riemer-Tiemann reaction. Pyrrole is reacted with a strong base and a chloroform. The strong base is KOH and chloroform CHCl3 in the Riemer-Tiemann reaction to form a pyrrole 2-aldehyde is obtained. Then Willsmere-Hack reaction. Then the chemical reaction is Willsmere-Hack reaction. Pyrrole may be formulated by heating it with phosphorus oxychloride and dimethyl formamide. So pyrrole is treated with phosphorus oxychloride, POCl3, phosphorus oxychloride and dimethyl formamide. Pyrrole is treated with phosphorus oxychloride and dimethyl formamide. The intermediate is produced. Then it is hydrolyzed in the presence of mild base to form pyrrole carbaldehyde. So, first of all, pyrrole is formulated, then it is heated with phosphorus oxychloride and dimethyl formamide to form a intermediate product. Then it is hydrolyzed with, it is reacted with the water and sodium ethoxide CH3COO in the presence of a mild base, sodium ethoxide, to form pyrrole carbaldehyde. Okay. Then electrophilic substitution reaction. The electrophilic substitution takes place preferably at C2 or C5 position. Okay, the electrophilic substitution in pyrrole is maximum prefer in C2 or C5 position. If these positions are already occupied, then substitution takes place at C3 or C4 position. Okay, so the substitution reaction, electrophilic substitution reaction, maximum prefer in C2 or C5 position. Then this position is already occupied. Then the substitution is take place in another position, C3 and C4 positions. The electrophilic substitution reactions are, first of all, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, and halogenation. There are 5 electrophilic substitution reactions: nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, and halogenation. First of all, nitration. Nitration of pyrrole results in two products. One is a major product and one is the minor product. Pyrrole is reacted with nitric acid in the presence of sulfuric acid to form two products. One is major and another one is minor. 2-nitropyrrole and 3-nitropyrrole is obtained. 2-nitropyrrole and 3-nitropyrrole is obtained. 2-nitropyrrole is a major product and 3-nitropyrrole is a minor product. Okay, the nitration of pyrrole reaction is, pyrrole is treated with nitric acid in the presence of sulfuric acid to form a two product, 2-nitropyrrole and 3-nitropyrrole. The major product is 2-nitropyrrole and the minor product is 3-nitropyrrole. Then sulfonation. Pyrrole is reacted with the sulfuric acid in the presence of sulfuric acid, and it gives two products. One is major product and another one is minor product. So it is same as nitration. Pyrrole is sulfonated by sulfuric acid, and in the presence of sulfuric acid to form two product, 2-pyrrole sulfonic acid. Then second position is SO3H is obtained. So 2-pyrrole sulfonic acid and 3-pyrrole sulfonic acid is obtained. The major product is 2-pyrrole sulfonic acid and the minor product is 3-pyrrole sulfonic acid. The next one is halogenation. Pyrrole is reacted with chlorine in the presence of aluminum trichloride AlCl3, and it gives two products. One is major and another one is minor. Pyrrole is reacted with the chlorine Cl2 in the presence of AlCl3 to form two products. First one is 2-chloropyrrole, then second one is 3-chloropyrrole. The major product is 2-chloropyrrole, then minor product is 3-chloropyrrole. Okay, the pyrrole is reacted with the chlorine in the presence of aluminum trichloride. It gives two products, 2-chloropyrrole and 3-chloropyrrole. Then Friedel-Crafts alkylation. Pyrrole is reacted with alkyl group in the presence of AlCl3 and it gives two products. Pyrrole is reacted with an alkyl group in the presence of aluminum trichloride. It gives two products. One is major and another one is minor. Pyrrole is reacted with alkyl group CH3I. Aluminum chloride AlCl3 to form 2-methylpyrrole and 3-methylpyrrole. 2-methylpyrrole is a major product and 3-methylpyrrole is a minor product. Then Friedel-Crafts acylation. Pyrrole is reacted with the acyl group in the presence of AlCl3 and it gives two products. One is the major and another one is minor. Pyrrole is reacted with CH3COCl in the presence of AlCl3 to form 2-ethylpyrrole and 3-ethylpyrrole. 2-ethylpyrrole is a major product and the 3-ethylpyrrole is the minor product. So the chemical reactions are completed. Next one is medicinal uses. Pyrrole is used in narcotic industry for making tobacco. Then it is used in cardiac disease medicine and it is used in making pyrrole derivatives. It is used as antibacterial, antipsychotic, antimalarial, an anti-cancer, anti-muscarinic drug to treat Parkinsonism, and antifungal. These are the medicinal uses of pyrrole. It is a narcotic industry for making tobacco and a cardiac disease medicine, making pyrrole derivatives. It is used as antibacterial, antipsychotic, antimalarial, anti-cancer, and anti-muscarinic drug to treat them Parkinsonism and antifungal, and pyrrole is used as antifungal. So aromaticity of pyrrole. So the next heading is aromaticity of pyrrole. Pyrrole itself is completely planar and have molecular dimension. Pyrrole is completely planar structure and have a molecular dimension. The sp2 hybridized carbon atom, sustained 6 pi electron system. The sp2 hybridized carbon atom sustained 6 pi electron system. From the molecular orbital standpoint is consisting of planar pentagon with sp2 hybridized carbon atom. From the molecular orbital spectrum is consisting of planar pentagon with sp2 hybridized carbon atoms. Each of the 4 carbon atom has 1 electron remaining in a pz orbital. The nitrogen atom has 2 electron in p orbital. So the 4 carbon atoms has 1 electron remaining in a pz orbital. The nitrogen atom has 2 electron in p orbital. These p orbitals overlap to give a total of 6 electrons in pi system, and this shell provides stability. These p orbitals overlap to give a total of 6 electrons in pi system, and this shell provides stability. Pyrrole is an extremely weak base because its pair of non-bonding electrons are part of the pi cloud. Therefore, if pyrrole is protonated, it loses its aromaticity. So pyrrole is an extremely weak base because a pair of non-bonding electrons are part of the pi cloud. Therefore, as pyrrole is protonated, it loses its aromaticity. Okay. So in this class we will study about pyrrole. First of all, physical properties of pyrrole, then second, chemical properties of pyrrole, then synthesis of pyrrole in 5 methods. First one is from furan, then second one is polymer pyrrole synthesis, then third one is Hansen pyrrole synthesis, then fifth one is from distillation of succinamide. The next one is from acetylene and ammonia. Then next study the reactions of pyrrole. Next we studied the reactions of chemical reactions of pyrrole. First one is acylation, then second one is oxidation and reduction reaction, third one is ring expansion reaction, then Riemann-Tiemann reaction, Wilsmeyer-Hoek reaction, then electrophilic substitution reaction. First one is nitration, sulfonation, Friedel-Crafts alkylation, acylation, halogenation. First nitration, pyrrole is reacted with nitric acid to form 2 nitropyrrole and 3 nitropyrrole. Then second sulfonation, pyrrole is reacted with sulfuric acid to form 2 pyrrole sulfonic acid and 3 pyrrole sulfonic acid. Then halogenation, pyrrole is reacted with the chlorine to form 2 chloropyrrole and 3 chloropyrrole. Then Friedel-Crafts alkylation, pyrrole is reacted with methyl group, then to form 2 methylpyrrole and 3 methylpyrrole. Then acylation, pyrrole is reacted with CH3COCl to form 2 ethylpyrrole and 3 ethylpyrrole. Then medicinal uses of pyrrole, then aromaticity of pyrrole. Okay, thank you.